Number 3 on the puzzle piece study guide, in case you want help with that one too. L is looking at graphs of functions that have the same slope as 3x plus 2y equals 6. Which graph is L looking at? Choose all that are correct. So you know that it has the same slope as that equation, which is a linear function. So the reason why these are even in this unit is because linear functions are functions. All right, the full unit's called functions. So you have a few questions that you honestly probably could have had on your unit 2 test as well. So let's just hear again. So first you need to figure out what the slope is for 3x plus 2y equals 6. In what format can you most easily see the slope? In y equals mx plus b. So if I convert it to this format, and in order to do that, I would just have to get the y by itself. Then I can easily see my slope and then see which graph has the same one. So to get the y alone, start with what's farther. Would that be the 3x or the 2? And how do you cancel the 3x? Okay, good. And then I have 2y equals, and these are not like terms, so don't combine it and make it like 3 or something. One has an x, the other one doesn't. So what I would do is I would just change the order. I put the negative 3x first and the positive 6 second, just so it looks a bit more like this. All right, but the y is still not alone. So now you have to undo that. How do you cancel timesing by 2? Good. And don't forget to do it to both terms on the other side. And then your slope is allowed to be a fraction, so you could just leave that. And it is already simplified. What's 6 divided by 2? Okay, good. But all this question asked about was that it wants to have you pick graphs that have the same slope. So you need to be able to see equations in this format and be able to tell me the slope and the y-intercept on your real test. Okay, but so this is my slope. Slope is always what's in front of the x. I need to pick graphs that have a slope of -3/2. They may or may not be shuffled on your screen, so just make sure you know how to do it. See if this graph has a slope of -3/2. So find 2 parts that you can see really clearly, like there, and I want to say here. And each of these is counting like the axes. You also have to pay attention to that too. Each tick mark is counting by, it looks like 2s on each side. And because it's the same for the x and the y, that's fine. I can still count 1, 2, 3 down and to the right 2. Okay, so from the 2 areas that you can see really clearly, am I going down 1, 2, 3 and to the right 2 to get there? So then you're going to pick all the graphs that have that same slope. So the one that's first on my screen has the same slope. And the next one. So then find 2 parts that you can see really clearly. So I'll take this one and this one. For this one, do I look like I'm going down 3? So then don't pick that one. And the next one, I'm not even going to test because does that have a negative slope? No, it's going up from left to right. So I'm not even going to try that one because I know it won't. This one's going down, so let me find 2 parts that I can see really good. So like there, it goes right through like the little grid line, the crosshair. And then here also. So see, am I going down 3 to the right 2? Take that one, and it says select all. And then I'm not even gonna bother with this one because that should have a positive slope, not a negative one. Questions on that? So for this one, because it might be shuffled on this screen, 2 answers. that has the same slope as -3 over 2. All right, any other questions for right now? Going. Number 5 on this one. Okay. So Sarah's practicing her typing. I do think I need to fix the typo on here. Let me fix the change. Still doesn't affect the answer, but it might just affect how you read it. It should say W. Or maybe I'll just make it be, yeah, I'm gonna put it as a W. Okay. So anyway, Sarah is practicing her typing. The following shows her words per minute. At what average rate of change in words per minute does Sarah type from W of 1 to W of 3 and enter your answer as a decimal rounded to the nearest 10th? So, let's see. When you see the phrase average rate of change, what should you automatically be thinking of? It's the slope formula. Good. Does anyone remember what that formula is? Okay, good. So not y equals mx plus b because that's slope intercept form. You want just like for the m, which is also a rate of change. But not all the time are they going to be straight lines anymore. So we just use average rate of change as like a general phrase, but it's still the same formula. So now you just have to really pay attention to where they want you to look. Okay, so it'll always tell you, look from when x is this to when x is that. So where do they want us to look for this one? And what is usually in the parentheses? Our input. So they want to know from where the input is 1 to where the input is 3, what's my average rate of change? So you have to know what part of the table or graph or whatever coordinates that you need to look at. So I need to look from these 2 coordinates. And the way that you use this formula is you pick one of the coordinates to be x1, y1, the other one to be x2, y2, and then you just plug it in and solve. So the way that I labeled it, what's my y2? 176. What's my y1? 1. No. Oh. 63. So that's why I never skip the labeling step. And then what's my x2? And then what's my x1? But and it said minus in the formula, so there's minus there. And then you're just simplifying. So 176 minus 63 is 113, if I remember correctly. 3 minus 1 is 2. And then when I divide that in my calculator, I get good. And it did want my answer as a decimal rounded to the nearest 10th. And the nearest 10th is just 1 decimal spot. So that's already there. So then on that one, we really like modeled it after the test. So like if you have to drag and drop, you'll have to drag and drop on the test. If you have to type in the answer, you'll have to type it in on the test. So yeah. Other questions at all right now? Going? 8. Number 8. Okay. So we have length and area of various bins write an equation that best models the data. Let x be length and f of x be area. Use, and you're just typing it. Don't put any spaces when you type it in. So for this, and this is gonna be a big theme, especially next semester, but it's a question on your test, so you just kind of have to experience it now. But we already covered linear functions. So when you look at the table, do you see like any sort of pattern? When the x goes up, the y goes up. So you could kind of use like what we learned in unit 3, I guess. You could put that in a table in Desmos and see what it looks like and make a linear model from that. But one thing you might notice, how can I go from 144 to 179? What can I do to the 144 to get 179? It add 35. And then is that consistent throughout? If I add 35, do I get 214? Okay, good. And then if I add 35 again, do I get 249? Yeah. So if you see that, and then as the x is going up, it's just going up by 1 each time. This is called a linear function. So I'm having to add each time to get to the next row. And in linear functions, we know it's a constant rate of change. All right. So knowing that, I could make it something in y equals mx plus b. What would my slope be? It's going up by 35 each time. My rate of change is. So then I can put that for my slope. Now for my y-intercept, you have a few options. I'll tell you one way, and then I'll give you an easy thing to remember. So you have coordinates here, like these are x's, these are y's. You could just pick one, like the first one. Because we actually don't know what b is yet. And you can plug this in for y. And plug this in for x. And solve for what b is. So it's 35 times 1. Okay. Get the b alone. How do I cancel out this 35? Subtract it, whatever you do on one side. And then 144 minus 35 is 109. So that would be my y-intercept. And when you like test it out, if you put in, for example, 1 times 35 plus 109, you'll get 144. When you do 2 times 35 plus 109, that's how you get 179. So like, this is my model. It becomes 35x plus 109. Now, I know that seems like weird and kind of random, not necessarily what we did, but we did cover linear functions and average rate of change. So kind of remember that. And side note, your y-intercept is whenever x is 0. So since my first x is 1, I could just kind of work backwards. What's 144 minus 35? And that you could get the x-intercept a little bit easier if you want to. But that you have to know that format. That's why it's on the study guide, so that you can get that right on the test. Okay, so questions on that one. Okay, any others right now? Alright, so you have to get 80% or higher on your study guides before you can move on to other things. So, study guides, 80% or higher, including the practice constructed response, get that done. And I'll check it with my clipboard before you leave. Then I'll check in later too for more questions, but feel free to ask as you go.
That represents the pay Y after X hours of work for various jobs held by college graduates. Additional college graduates were asked about their hourly pay. Which of these combinations would make the relation not a function? So what do we know about functions? So you can't have an X that repeats with a different Y. So if we look at it before, and they mentioned it here, they said the way it's listed is a function, because as you can see, none of the X's repeat. So automatically that makes it a function. It wants to know which combinations would make it not a function if I added it to this list. So maybe write it as a coordinate and you'll be able to compare it better. So to write it as a coordinate, you need to know what's your input and what's your output. So is it the hours worked is my input, or is it that the pay is my input? So then, okay, so it goes hours and then pay. So then all of these are sorted hours first and then the pay. So if I put these all as coordinates and I added them to my list, we want to know which ones make it no longer a function. So pay attention to what each represents. It could be that they said $100 pay for 3 hours, but you still need to write it with the hours as the input. So then which of these would make it not a function? Good one. Are there any others? And then any others after that? Okay, so then class, do you think we have all of them that would make them not a function? Or do you think there needs to be any others? So if I were to add any of these 3 coordinates that we selected, then that makes it to where we have an X repeating with a different Y, but actually let's look at it more closely. So like this would be same X, different Y, right? 110 and 100 are different. So that would make it not a function. For this one, it's same X, different Y's. So that makes it not a function. Here again, we already had 9 as an X, and that would be a different Y. And then we do not have a 10, 8, or a 3 as an X. So if I were to add those to my list, it would be a function, but these ones make it not a function. Does that make sense? Okay, let me make sure the key is right. And it is. Any other questions? We might have time for 1 or 2 more. Some of you didn't have the constructed response done, so is it because we didn't understand any of them? Didn't? From the constructed response? Yeah. Okay. So also, I was looking at this and I kind of changed my mind to what I said to you guys earlier, if you want to make this adjustment. I was thinking more along the line of the test, where on the test, something was impossible that made you want to leave it as dots. Here, I suppose it is possible to have it where I guess if it's a half hour, it charge 2 times whatever half an hour is. If you guys want to make that adjustment, we did this part earlier. I do think this is linear up until the 3, and then it's like that.
The only change I made was I connected the first line. All right, now. We drew the graph, we said it is a piecewise function. Here's what I put for the domain and range. So the domain refers to all the what in a function. All the x's, which, and then if you look at the two things being compared, or the graph again, hours was on the x and cost was on the y. So we had to see like, what's a reasonable hour that someone could have left their dog at the dog sitter. Okay, so my smallest x from my graph was 0. So it could start at 0. I didn't include 0 though, because obviously if you're leaving the dog there for 0 time, you don't have to pay anything. So I just didn't put the equal to part. And it didn't say like the maximum time you can leave your dog there. If it did, I would have put whatever maximum time they said. So I just did whatever was on the x-axis as their maximum time. But on the test, it'll be really clear what the maximum time is. And the reason why I wrote it like this, so don't just copy it without listening, make sure you listen too. The reason I wrote it like this is because could I have a fraction of an hour? Could I have like minutes, seconds, right? So it's not like the dog is there for just an hour and never like a minute or second over that. So I can do all the values from 0 to 12, or all real numbers from 0 to 12. If you did it in words, I would accept it too. As long as you use the right words. Now for the range, because I decided, yeah, it is linear from here to here, and then it becomes more like pieced after that. Couldn't they charge like pennies, I guess? If a dog was there for a fraction of an hour, couldn't they charge 2 times however long they were there? I'm gonna go with they could have, because they didn't say otherwise. So from here to here, it was a continuous line. So it could be anything from 0 to 6. But then after that, the cost was 12 no matter what. So going based off the graph we drew earlier, they're charging anywhere from 0 to 6, nothing from 6, nothing like from 6 to like 11.99, and then 12 for everything else. So all real numbers from 0 to 6, and then 12. That makes sense? Any questions? So just whatever situation it is, make sure you think of like the real world context. And you buy half a cell phone and you buy half a pizza. No, and don't connect the dots.